on, everybody? It's your boy Average Leader here with another video, and today we are tackling number 2367, number of arithmetic triplets. Man, I can't say that word, arithmetic. Man, I should have practiced before making this video, but so yeah, there's a pretty new problem, and let's just dive into it. So you were given a zero-indexed, strictly increasing integer array nums and a positive integer diff. A triplet, ijk, is an arithmetic triplet if the following conditions are met. I is less than j is less than k. So we have three indices where I is less than j is less than k. Okay, that makes sense. The number at index j minus the number at index I equals the diff provided. And the number at index k minus the number at index j equals the diff as well. And these are the three criteria required to have an arithmetic triplet. So the goal here is to return the number of unique arithmetic triplets in our array. And we have this example right here. I'm thinking let's grab this example and take it over to the iPad where we can kind of dissect it and go from there. Alright, so here is the example that they gave in that last problem, number of arithmetic triplets. So here is our input nums array that we had, and then we have a diff of 3, and we have an output of 2. So how did we get this output from this input in the problem? We're trying to find arithmetic triplets, and we're trying to find the number of them. So, and based on the example given to us in the problem, how do we get this output right here of 2? Well, let's start with what is an arithmetic triplet. Well, they defined it as any three indices, I, j, and k, where I is less than j and j is less than k. So basically I comes before j and j comes before k. And an arithmetic triplet is such that the number at j minus the number at I, so here j is 4, I is 1, equals the difference, which is 3 that we have in this case. And also the number at k minus the number at j, which in this case k is 7, j is 4, equals the difference as well. So we need to find as many triplets that fit this criteria to, output back to our interviewer, or I guess in this case Leetcode. So let's think now, how can I find every single arithmetic triplet? Well, let's take a look at one of those triplets one more time. So we have 1, 4, and 7 here, right? That's one of the triplets. So notice that 4 minus the diff, which is 3, 4 minus 3 is 1, and 7 minus 6 is 1, right? Or in other words, 7 minus the difference times 2 is 1. So one possible, brute force idea that I would start out with is maybe iterating through all of the numbers in our array and placing a value that is a difference of 3 from the original value. So in this case, at index 0, we have 0 minus 3, which is negative 3, 1 minus 3, which is negative 2, 4 minus 3, which is 1, 6 minus 3, which is 3, 4, and 7. And as we're doing that, now we have all elements that are a difference of, one interval difference away from our original number. Now, we need an interval that's one difference away as well as two differences away, since the difference between I, j, and k have to be the same. So we also want, as we're creating this array right here, we should also try and create an array that with all elements that are 2 times the difference away. So as we're making our first array, we should also go ahead and make our second array, which is 2 times the difference away. So we'd have 0 minus 6, which is minus 6, 1 minus 6, which is minus 5, 4 minus 6, which is minus 2, 0, 1, and 4. Okay, great. So now we have all the differences of 3 and all the differences of 6 away from our original number. Now it's just a matter of finding all the differences of 3 and the differences of 6 that were in our original array. So, in this case, minus 3 and minus 6 weren't in our original array, minus 2, minus 5 weren't, and, this 1 minus 2 weren't, but all the numbers after that aside from this 3 right here, I guess, are in our original array. So is there a data structure that we can use that can hold on to values so we can check back later to see if that data structure contained what we're looking for? One very efficient data structure we can use is a hash set that would help us tremendously in this case. So I'm thinking we'll have this hash set right here, and as we're iterating through the array for the first time around, and during that first iteration we would create this array of all numbers of 1 difference away as from the original number, as well as 2 differences away. So we create 2 arrays at that same time. On that first iteration, we can also put all of the numbers in our original array in our hash set. So now in our hash set, what will we have? By the end of the iteration, we'd have 0, 1, 4, 6, 7, and 10. Okay, perfect. So now we have a data structure that we can use to see if we've seen a number already. So with all these pieces, the last thing we'd really have to do is iterate through both of our new diff arrays that we had created, 1 difference away and 2 difference away from the original number. And on each iteration, we would just do a quick check to see if both of these numbers are in our hash set. So we'd go through index 0 here and check, is -3 and -6 in our hash set? We'd say no, since they're both negative. Then we go to the next, and we say the same. Then we go to the next, and we say 1 is in our hash set. Okay, that's good. But -2 isn't in our hash set, so we say, so we're not going to do anything. We'll go on to the next. Now we have 3 and 0. So 3 isn't in our hash set, but 0 is. So, we need both numbers in for this to work. So we're going to go to the next one. And now we have 4 and 1. And notice that this is at, when we're at number 7 in our original input array. So now we're going to do a quick check. Does our hash set have 4? Well, yes, it does. It's right there. Does our hash set have 1? Yes, it does, right there. So anytime we match that condition, we want to increment a counter, which would be the thing that we'd return. So right now our return value is going to be 1 because we have 1 triplet so far that matches all our criteria. And then we go into the last number in our arrays, and we have 7 and 4. Now we ask ourselves, is 7 in the hash set? Yes, it is. Is 4 in our hash set? Yes, it is. So guess what? Since both of those conditions are met, we have another arithmetic triplet. So we would increment our return value by 1, and hence we get a return number of 2. And that's perfect because that is what our output is in the example. So, okay, so this is all good. This is all fine and dandy. But I guess we got to ask ourselves, was it really necessary to store all of the numbers that are 1 difference and 2 differences away from our original number? Was it important to store all of that in 2 more, units of storage? We essentially made our space complexity O of 3 times n. 1n, which would be considered in our first diff array. Our second n would come from the, everything that's a diff times 2 away. And our third n would come from our hash set. So it still does dwindle down to an O of n space complexity, which is still fine, but this isn't, the most efficient way to do it because we're using so much extra storage. So now we got to start thinking to ourselves, how can we make our storage and time complexities a little bit better? Well, so from a storage perspective, maybe we can start thinking of a way to not really use the additional arrays that we built, but instead really relying on our hash set right here, because that's really where all the magic's happening. We kind of went through both of our diff arrays that we had created and did some checks to see if both differences were in our hash set that we had created. Well, we can kind of simulate that same idea since we know that all the numbers are going to be in increasing order. So that's advantageous to us because we can do basically everything we were talking about in just one single iteration of our input array. And how would we do that? Well, let me show you. So all we are going to really rely on is our hash set that we had created. okay? And let's just pretend it's an empty hash set. So kind of thinking about that same idea that we used to start this thing, what we want to do is iterate through each of our elements in our input array once, okay? So we start at 0. And now we would say are the differences of 0 minus 3 and 0 minus 6 in our hash set? So we just do a quick check. Is 0 minus 3 and 0 minus 6 in our hash set? Well, our hash set is empty right now, so that is obviously false. And since it's false, we're not going to increment a counter or anything like that. And before moving on to the next number, the last thing we're going to want to do is put that number that we had just seen in our hash set, because any of the future numbers we see in our array can utilize this number that we just put in our hash set as one of the numbers in the arithmetic triplet. So moving on to 1, we would do the same thing. We'd ask ourselves, is -2 and -5 in our hash set? No, we just have 0. So since that condition is false, we don't increment anything, so we're going to now add 1 to our hash set. Then we go to 4. And we ask ourselves, is 4 minus 3 in our hash set? Yes, it is. Great. Look at that. That's how we're using previous values in our arithmetic triplet. Now, but guess what? 4 minus 6 isn't in our hash set, so we're not going to do anything about that. Then we're going to finish and put 4 in our hash set. Then we get to 6. Now we ask ourselves, is 6 minus 3 in our hash set? Nope. 6 minus 0 in our hash set? Yes, but it doesn't matter since 3 isn't in our hash set, so now we're going to finish and put 6 in our hash set. And now the beauty comes when we look at 7, since we know that it's one of our, 2 triplets that we have here. Now we got to ask ourselves, is 7 minus the diff, which is 3, in our hash set? So is 7 minus 3 4 in our hash set? Yes, it is. We see that. Then we ask ourselves, is 7 minus 2 times 3, 2 times the diff in our hash set, which is 1? We'll look at that. Yes, it is. So since both of those conditions are met, we would have like a return variable right here with a value of 0 to start off with. Now, after both those conditions are true, we would add 1 to this return value, so we'd have 1 right now. And right before we move on, we want to add 7 to our hash set. So finally, we would go to the value number 10. Now we'd ask ourselves, is 10 minus the diff in our hash set? In this case, it's 7, so yes, it is. It's right there. And we'd say, is 10 minus 2 times 3 in our hash set, which is 4? Yes, it is. It's right there. So we go ahead and increment our return value counter to 1 and add another 1. So now our return value is now 2. So, and then the last step we do is add 10 to our hash set, and that's it. So we had drastically cut down our space complexity from an O of 3n to O of n, which is pretty solid in an interview. That's what they're kind of looking for. They want to see just a reduction of complexities. And even though O of 3 to the n does end up, becoming O of n, even without doing these, efficiencies, it's still pretty good that we had a base of O of n and nothing else after that. And if you think about our time complexity, originally we would have to do like a few iterations, one iteration to put everything in our hash set, or one iteration to put everything in our hash set, and in that same iteration we would make those 2 other diff arrays, and then we would iterate again through the diff arrays and do those checks with our hash set that I had mentioned before. So that would be an O of 2n time complexity, which now, since we're only going to do one iteration through the input array just one time, that becomes an O of n as well. So those are your time and space complexity. So this is the basic idea that we're going to use, and now let's go ahead and code this out. Here is what the code looks like. So just like in our example, we would start with the creation of a hash set. This is going to be the data structure that we use to check what we've seen before already. And then I went ahead and initialized my return value. This is going to be the thing that we're going to increment every time we have something that meets all of our conditions that we talked about in the example. Specifically, the conditions are going to be if we've seen a number minus the difference as well as the number minus the difference times 2 in our hash set, then we're going to increment our counter. So now we're just going to iterate through our nums array, and every time we access a number in our array, we're just going to check to see if our hash set contains the number that we're at minus our difference, and we're going to check to see if the hash set contains the number minus 2 times the difference. And if both of those conditions are met, like we talked about in the iPad, we're going to increment our return value. And the last step we're going to do, just so we can build future arithmetic values with our current value that we're at, we're just going to add the current value that we're at in our hash set, and that's it. The for loop is, pretty simple, and it's going to follow this logic for every single number that we're at. At the end of this for loop, we're going to have our return value, with all the arithmetic triplets in our array. So if I go ahead and submit this, you see that we pass it. So yeah, that is how you do this problem, y'all. And yeah, that's all I have for you. So let me know what you thought about this style of video where I put more emphasis in the intuition and the iPad and the drawings and stuff, and spend a little less time on the code. I'll have it all written out for you. And yeah, just think about if this was more helpful than me coding it out myself after going through the intuition stuff. But yeah, if you found any value from this video, go ahead and give this video a like and subscribe to the channel. And comment down below on any other problems you want to see me do. I'll go ahead and do that for you. And yeah, everyone, hope you have a great rest of the day. I'll talk to y'all next time.